Okay, hello everyone. My name is Joseph Mikkel, and for my presentation, I've decided to present a topic which I am personally very passionate about. And that topic in general is cars. But specifically, I will be covering a certain part of a car, and that is the turbocharger. I'll be going over the operating principles of this device. So just as a beginning overview, the main function of a turbocharger is to maximize the efficiency of the engine, mostly in terms of power. I will be going through a step-by-step process on how this small yet insanely powerful device works. So, to begin with, I'm sure a lot of you are wondering, what is a turbocharger? Well, I'm here to tell you. So a turbocharger is basically a small air compressor which runs off of the car's exhaust fumes. So as I stated before, its purpose is to increase the power output and even fuel efficiency of an engine. It generates power by forcing large volumes of air into the engine, which when combined with proportionate amounts of fuel it's ignited to create a more powerful combustion cycle, which results to more power being made from your engine. So there are two main parts of the turbo. Turbo is of course short for turbocharger. If you look at this graphic on this presentation slide, the left side of the graphic is the compressor housing of the turbo, and the right side is the turbine section. I'll be going over each part accordingly. So the first step in a turbo's function is the engine cylinder combustion. So since a turbo runs off of exhaust gases, the engine first has to fire or produce combustion in order to generate those fumes. Now, combustion is simply the term for ignition of the air-fuel mixture within each engine cylinder. So basically, combustion is a explosion that happens, a confined explosion that happens within each engine cylinder. The fumes exit the engine through the exhaust manifold. So the manifold is a series of pipes that route the fumes from the engine directly into the turbine housing of the turbocharger. If we go back to slide 1, you can refer to the right side of this graphic as the turbine housing or turbine section. Now in this graphic, those four large pipes, that whole section right there is your exhaust manifold. If you look at the right side of the exhaust manifold, you'll see that it's connected to a series of four holes on the engine block. Each hole is the end of an engine cylinder. So like I said before, in each of those four cylinders, there's combustion happening inside, and there are independent exhaust fumes exiting each cylinder. So you have a total of four sources of exhaust fumes entering the exhaust manifold. They're all collected within that manifold, and as you can see at the left end, they're all routed into the turbocharger. Now, the second step after combustion is compression. So as the fumes pass through the turbine housing of the turbocharger, they pass over a turbine, or basically a small fan, which spins from the kinetic energy of the gases. So basically imagine blowing on a fan and the fan spinning. That's the same effect that the gases have on the turbine. So then the gases then exit the vehicle through the vehicle's exhaust system. Now I'm sure we all know what an exhaust looks like. It's basically just the tailpipes coming out of the end of your car. If you refer to the graphic on this slide, you'll see that the red section to the right, you can see the arrow which points towards the exhaust system. So the exhaust fumes enter the red section of the turbo, which I said is the turbine housing, and they exit through the exhaust through the right end. So if you look at the graphic, you can see that the turbine wheel or the turbine itself is connected to a compressor wheel, which is basically another fan, but that is on the compressor housing. It's inside the compressor housing. Since they're both attached by that bearing in the middle, both the compressor wheel and the turbine wheel spin at the same time and at the same frequency or at the same speed. So as the compressor wheel spins, which is now the left half of the turbocharger in this graphic, as the compressor wheel spins, it sucks in fresh ambient air into the turbocharger and is then compressed and pressurized within the turbo. After the compression and or pressurization happens, that compressed air leaves the turbo and then enters into something called the intercooler. Now I know there are a lot of long, difficult words here, but I'll make sure to explain it. So, what is an intercooler? So, like I said, we have the superheated, compressed air coming out of the turbocharger. It's so hot that it has to be cooled down before re-entering the engine. Otherwise, it won't be burned efficiently. The purpose of the intercooler is to lower the temperature of that pressurized air coming out of the turbo. So the intercooler uses ambient air to cool down the compressed air from the turbo, like I just said. So this is how the intercooler functions. It's a really simple device. So as you're driving, air from outside hits the front of your car, obviously. That's where the intercooler is located, right at the front. That air that hits the intercooler cools down these fins that you see in this graphic that are located inside the intercooler. Now, as the hot compressed air from the turbo passes through the intercooler, it passes over or through these fins, and then heat exchange occurs so that the so that the hot air from the turbo is cooled significantly, and then the cool fins on the intercooler are heated. And then the fins are cooled again by the action of the air hitting the front of the car. Now, the third and final step in the turbocharging process is the air re-entering the engine. Now, at this point, after the air leaves the intercooler, the air which before was superheated is now significantly colder, making it much more dense. Like I said, it's dense because of the compression and the pressurization, as well as the cooling. So when this dense air enters back into the engines, it enters back into the cylinders and is mixed with fuel and is ignited. Now, when it's ignited, combustion happens again, and combustion creates the energy used to move the car. Now, after combustion happens, the cycle starts all over again. And that's basically it. It's a relatively simple process. There are a lot of moving parts, but if you think about it, it's pretty simple. So here's a general infographic of the whole process. So I'll review it one more time. If we start at the left end at the engine cylinder, combustion occurs, exhaust fumes leave the cylinder through the exhaust manifold. The exhaust fumes enter the turbocharger through the turbine housing. The kinetic energy from the gases spin the turbine wheel, which in turn spins the compressor wheel. As the compressor wheel spins, it sucks in ambient air and compresses it. That compressed ambient air leaves the turbo, travels through the intercooler, and as it travels through the intercooler, it is significantly cooled. The temperature goes down. And after it leaves the intercooler, it re-enters the engine where combustion happens and the cycle starts all over again. So in conclusion, um, the whole point of a turbo, like I said, is to make an engine much more efficient. Most people turbocharge their cars or buy a turbocharged car from the factory because it produces more power. But also, there's a lot of potential for aftermarket support. It also allows for better fuel economy. That is because a turbocharged four-cylinder engine usually makes the same amount of power as a naturally aspirated six-cylinder engine. But since there are two less cylinders, you get better fuel economy from the four-cylinder while getting the same amount of power. To me, the only downsides are the maintenance costs and also the reliability. You have much more moving parts so that there's a higher chance of something breaking or something going wrong. And that's pretty much it. I hope it wasn't too difficult, and I hope I taught you all something today. Thank you.